and we'll talk about why that's important later on. But this is an angle side angle.
Wait, Coach Jay, is that this is a right triangle?
It is not because there's no 90 degrees.
Okay, I was gonna.
Does that make sense? Because if these two added together, what would be this angle here? 60. Good. Give yourself 2, Mason. That's 60 degrees. Notice there's no 90-degree angle. So what we cannot do is, because there's no 90, we can't use SOHCAHTOA because it won't actually work. So we have this thing called the law of sines, okay? The law of sines says this, that the sine of the angle over the opposite side is equal to the sine of the angle over the opposite side, okay? So literally, this is the formula. It's sine of big A, which is the angle, over the side length of A, equals the sine of big B over the little b, and equals sine of big C over little c. Okay? I don't think it's very difficult. Largely, in fact, a lot of people do better on this than the SOHCAHTOA part. But what we're going to try to do is progress with what we know. So if we did the sine of 60, which is the angle we just solved for, that would be over top of what, Rosemary? I actually am. Oh. Yes, ma'am. I did it before y'all got in here, just so I wouldn't forget, because I know I do forget. Do you know, since you reminded me, what would be the side length across from 60 degrees? Yeah, 20 feet, right? So we're just going to put 20 on the bottom, and that is equal to, give yourself 2, by the way, is equal to what? How could I solve for x here? What is the angle across from x?
Oh, it's equal to,
sine of 40
over x. Nicely done. And that's how we would solve for x here. So we could use any two angles / sides, setting them equal to each other to solve for the angle or the side that we're trying to solve for. So what would I need to do to solve for this?
Get x by itself.
Get x by itself by cross multiplying. We got to cross because it's equal to here, not multiplying. So that's one thing to remember. We would have x sine of 60 equal to 20 sine of 40. Good. And how would I get x by itself?
Divide by sine of 60.
Good. Good, David. Give yourself 2 on that, man. You're racking it in this morning. Sine of 60, and we rock and roll. Could someone real quick make sure you're in degree mode, 20 sine of 40, and then divide that by sine of 60. Tell me what you get.
14.84.
Great. Yeah, thank you, Audrey. Give yourself 2 on that. 14.84. So Coach Jay hit this thing 14.84 feet. Now, that could be a short joke, and I get that. That's not very far. Maybe we'll say, I can't even make that good.
Threw me off. The drawing of your triangle. I thought it was going to be like 40 feet at least.
Oh, it looks that way, right?
Yeah.
Does anyone know why it would actually be smaller than 20 feet?
Because it's opposite from the smallest angle.
Good, David. Give yourself 2 on that. What would be you're rocking today. What would be the largest side, someone other than David? Caitlin?
Across from 80.
Good, because the largest angle corresponds to the opposite of the largest side. Does that make sense? Just a way to check it. Okay? Give yourself 2 on that, Caitlin. That's rocking. All right. Questions on that? Does that ring a bell from last year at all?
It does. It rings a big one.
Does it? Okay, good. Hey, I did have this chart. Did y'all use this chart last year? Right here?
Yeah.
Yes. I think this chart's excellent. I think it's a big help. Basically, the 2 that you need to kind of know, this is up here, section 6.1. Down below, we're going to do this, 6.2. The project will be based off both of them, okay? So I'll be helping you throughout the course of this week. These 2 up here are the ones where we use basic law of sines, what we just did right here, okay? So if you had side angle angle or angle side angle, really if you have 2 angles, you just do it the basic way of what we just did, okay? The problem is when we have the third one, right? Okay, and we'll talk about that later on. SSA, or if you're really feeling gutsy, ASS, okay? And we'll talk about that today. What's that?
What's that spell?
Ass. It's in the Bible. We can say it. Turn me in. See what happens. No, I'm joking. No, I'm joking. Is this podcasted? Oh, my God. I'm going to have to redo this podcast.
Turn me in. See what happens.
Olivia's over here ready to text in.
Text about it. Text about it.
No, don't text about it. No.
Are you going to text about it?
can.
Text you about it.
Cool. All right. Offended there. All right, hey, let's do this just as a quick rep. We're going to do, I don't think we need a ton of these. I'm not trying to overwhelm you on this. In fact, do this. Go to the homework real quick, and let's go to, I think I want to match one up. Is there one that's matched up with those two there? I don't know if I did that or not. Do this. Do number one. On the box. Cool. Tell you what, we can hold off on that. Go to number one real quick. I want you to solve for the C and B, all the missing sides and angles, okay? So I just want you to rep that out, try that out real quick, and that way we're getting a homework problem done. If you have some questions, we'll stop and kind of go through that as well. I think it might be 45. All right, I've got this one here. This one's number one again. Again, we're looking at number one on the homework. If you're doing it on the notes, that's fine too. That's fine. I just want to make sure you get one rep in. Sure, it's sine of 45 over 2. That's right. Good.
Coach Jay, once I find two of the sides, can I just be lazy and do Pythagorean theorem?
I can't on this because it's no 90-degree angle.
Oh, okay.
I was actually just writing that. That's a great question. So when we do these ones, that's the one thing that you got to be careful of that people mess up on sometimes. Pythagorean theorem you actually can't use here.
Got you.
So you just got to do it one more time again. Let's see here, coming here. This is two angles. Here. So again, we can do it the basic way as long as we have two angles. That will always be the basic law of sines, what you're doing right now.
Do you want us to what do you want us to round to? There's 10th or just nearest?
I would say round to the nearest. How about the first decimal? We'll do that for everything.
Got it.
We'll just do the first decimal for everything. That way it makes it a little bit easier there. The way we're consistent. Cool, cool. Is there anyone struggling on this? I know I did one example, so if you're not quite there, that's okay. I wanted you to kind of feel it out, see how you're doing with it, and then roll from there. If you're feeling good, go ahead and number 2. That way you're getting another one done. What I'll do for those that are struggling, I just want to make sure I rep out this first homework problem, make sure that you kind of have it squared away, and then we'll go from there. The first thing is, why are we doing the basic version of this? Why aren't we going into anything else? Every time we have how many angles?
3. Wait.
Yeah, we always have 3, but if I'm given 2, right, we just do the basic law of sines. So we could say 30 plus 45 subtracted from 180 gets me 105, is that right? Okay, cool. So 105 degrees is what we put for our first angle, and that would be angle what again?
C.
Angle C, because it's across from side C. Good. Good, David. Does anyone, just quickly for some tickets, help me out with how you set this up?
You do sine A over little a equals sine B over little b.
Nice. And what did you plug in for that, Hannah?
Sine 30 over 20
Nice. Yep.
equals sine 45 over b.
Sine of 45 over b. Nicely done. And how'd you approach that in the next part?
Cross multiply.
Good. Yeah, we cross multiplied here.
Then get b by itself.
Nice.
Divide by sine 30.
Good. So we divide by sine of 30 here. Good. So when we do 20 sine of 45, do that first. That's one thing too. Get that answer, then divide by sine of 30. What'd you get, Hannah?
28.3.
28.3.
You said to round to the first
Sounded great.
I
Yeah,
got 28.3 with the round.
that's perfect. Yeah, if you did that, your money. Your money. Give yourself 2 there, Hannah. Nicely done. So that would be side B. Did anyone get side C? Just throw it out there. Devin, go ahead.
38.5.
Good. Did everyone else get that?
No.
I got
I got
38.6.
I did not.
I got 38.6.
38.5 or 6. If you're
I think I
close
did
on that, I'm
something
good.
wrong.
So we'll say 38.5. If you put 6 and it was rounded up, that's fine as well. Depending on how you rounded earlier, that could affect your total on that as well, okay?
I did it again with the A sides because we definitely had those. So like, maybe if they did it with the B sides because they rounded, maybe they did it. But like, I did it with the A sides because there was no decimal, it was simpler. So
Perfect, Mason. Did you get the same thing? Gotcha. Hey, here's the thing. If you round differently or if you approach it differently, like you use the other side, and it's off by what, like, let's say 0.5, 0.6, I'm going to give that to you. As long as you rounded appropriately and did it that way, I'm going to be good to go. I'll be G to G on that, okay? Cool.
Gotcha.
Questions on this one? How does law of signs basic, do you feel okay on that?
Yeah.
I know I went and hit it hard, or just hit it quickly. I didn't really hit it hard. Y'all feel okay on that? So again, basic law of signs. This is like no questions asked. We go into this. We do this when? 2 angles every time. Very good, Rosemary. Give yourself 2 on that. So anytime there's 2 angles, angle, side, or side, angle, we go ahead and we approach it with basic law of signs. Cool? Gucci?
Gucci.
All right, question real quick before we get to the next one. What type of triangle was this before we did what was in blue? Someone raise your hand and help me. What type of triangle was it before I put what was in blue, which is all the work that I did?
Angle side.
Why is it angle, side?
Because you see how it goes like 30, 45 side.
Yep. Why couldn't I say angle, side, angle?
Because you see how it like skips the little angle right there,
Yeah.
and that side is missing too. So like you can't like skip the missing ones or whatever. You get
No, I see.
I always say you can't
Yeah.
skip 2 things. I can't skip a side and an angle to go one way. That's going to be very important for where we're headed. Cool? Especially for the ASS triangles. Okay? Does that make sense? So it's angle, side, or you could say side, angle. You can do that way. But I can't skip over 2 things. Okay? Are y'all Gucci? All right, here we go. Next example, we're going to kind of transition off of basic law of signs, and we're going to go to my favorite type of law of signs, the ASS triangles. Okay? All right. So, how many of you are Walking Dead fans? Any Walking Dead fans? No? Wow, this illustration may flop, so if it is, I apologize. One of my favorite things with, any of these ones here, let me see if I got it. Thought I had it up here. Here we are. One of my favorite scenes is within the first episode when they're kind of filming around Atlanta, and you'll see kind of just different things. I'm always like, oh yeah, I know where that's at, and that's at. Does anyone know where this is at?
Yeah, that's the Westin. That's the Westin right there, that circular building.
Yeah, I love that building. Probably one of my
That's
favorites.
400.
Yeah.
This is 400. Yep, going down.
Yeah, that's who the trains.
Kind of going down here. I think it kind of comes to some other stuff too. Who's a Walking Dead fan again? Mason, you are, right? I thought we've talked about it.
They filmed right next to the
It's funny to see the quality of video compared
I know
to
that building.
the last few years.
I've lived
I
there.
hate you. Don't say that.
Yeah.
I know where that is. I went there.
Time out, how did they do this? Because I
Are you in
didn't know
degree
what
mode, maybe? You want to
Yeah.
check the mode real quick?
I'm in lock
You're in degree mode?
Yes.
Could I see? So, real quick, as you're noticing this, I've got a problem that relates to it, so I just wanted to kind of, just for fun real quick, make sure you put the 12 in front of the sign. So 12 sine of 90. Does that make sense?
Yeah.
If you do that, you're good. So I wanted to just show that to you. Does anyone know where that is? I can't figure that one out.
No, that's a bridge. I've crossed that bridge before.
Is that like to Midtown?
Yeah.
To like you're headed to IKEA?
Yeah, I've crossed that before.
Think of the traffic that was there for this day. I was just
It must have been
crazy.
horrible traffic.
They filmed near the seminary college my parents had to go to.
Oh, really?
Yeah, they filmed
Yeah,
there.
look at that building.
Marietta Street, there that is. Yeah, there's Georgia State. Yeah, but that's kind of funny. Georgia State got in there. So I wanted to just quickly show that to you because I wanted to give you a problem that's relevant to just The Walking Dead. And I love using illustrations and examples. And you'll always ask me, hey, Coach, when will I ever use this? And at least with law of sines and cosines and what we're focusing on, it's used a lot more than what we've done in the other units there. I almost died there. Almost died. Let me put this down before I get killed. Good God. Bianca just looked at me like, you thought that was funny. I got you. Hey, so as we're looking at this, one of our favorite spots as a family to go to is kind of over near Savannah, which if you look, it's in the bottom or on the right side of Georgia. And if you don't know about The Walking Dead, just as a quick illustration, just quick thing, they were always trying to head to Terminus. So they were trying to go from Atlanta and traveling to Terminus, and a lot of the episodes, a lot of the seasons are them going from Atlanta to Terminus and the journey and that sort of thing. So
what is Terminus?
Terminus was, it's when you want to,
Safe haven?
Yeah, sanctuary, safe camp.
from the zombies, right? So it's like a safe haven type thing from them. So they were trying to get there. Cool. So I know I'm going to draw this triangle in a second, but this is 250 miles. I researched this. This is real stuff here. From Atlanta to Savannah, straight there, 250 miles. And there's a 12-degree angle between Terminus, Savannah, and Atlanta. So the question is what is the distance between Atlanta to Terminus is what we're trying to find. Well, when we do this, the problem with this whole situation here is when we go from Atlanta to Terminus to Savannah, we do not have enough information to say that we have one definitive triangle. So this is 12 degrees. This is 250 miles. And I think I also put that 150. Good. Yeah, so this is 150. So what type of triangle would this be? Side angle side, right? Well, question real quick, as we backtrack before we end up trying to solve this thing, side angle side, we can't use what?
Law of sines.
Why? We can't use the law of sines, and we're going to get into that later on. Why?
There's no opposite things. Like there's no set. Like you can't have like a sine A over A because you don't have both of the things for any of them.
Yeah, that's exactly right. Because when we look at this, is there a way that we could set up the sine of this angle over this side? There's no corresponding angles. Does that make sense? So that's why we would use the law of cosines, which we'll get to in 6.2. But let's say we did this. If I said, hey, let's solve for the missing angles and sides, and I said this was from Atlanta to Terminus in the illustration I was using, that this was in fact 70 miles here. If I was solving for x here, what type of triangle would this be? Side-side angle. Or, if you're feeling gutsy, angle side-side, okay? So if you were putting that on there, that would be both the same. In this instance, within an angle side-side or a side-side angle, you actually do not have enough information to do two triangles, okay? So this is where it gets a little bit tricky. If you see, here's what I would say, if you see an ASS or an SSA, you got to watch out, okay? You just got to watch out. Because in this instance, we could possibly we do not have enough information to say definitively whether it will be just one triangle. It possibly could be 0, 1, or 2 triangles, depending on how we could solve here, okay? All right, so how do we approach that? How do we do it? Well, with The Walking Dead, that was a good illustration to kind of set this up. But what I want to do is kind of go into one of these problems here and see if we can solve it ourselves, okay? All right, so here we go. This is going to be off of our notes here. I want to do one of these on this side. You kind of can see, by the way, down here where we could have possibly no triangle, one triangle, or 2 triangles, and that would be kind of what they would look like there, okay? All right, so let's take a look at this. We're going to set up just a random triangle. We've got angle A, side A, angle B, side B, angle C, side C. As long as they're across from each other, I'm fine with putting them wherever you want to, okay? All right, so 10 goes here. Okay, so we got 10 here. Where does 30 degrees go?
Big A.
Big A, which is across from, yeah, good, David. Give yourself 2 there, David. That's good. And then we have B, which is 40 here. And there we are. All right, what type of triangle is this?
Side angle.
You almost cussed, didn't you? That was really disappointing, Hannah. I'm joking. I'm messing. I'm going to put it down because I like it. I like putting it down, okay? All right? If I was getting observed, I'd still put it down. They can't do anything to me.
Coach J.
That's right. That's right. So when we see an ash triangle, we got to watch out because why?
Because it's a...
I'm cussing in class right now a lot on this podcast. I can't use this one, so we're just going to keep going in, okay? So it could be either 0, 1, or 2 triangles. What's that?
So can you please post this one?
Post this one?
Just to
No, because y'all are going to like Snapchat it. My teacher's cussing. Ha ha, that's funny. And then I'm going to get talked to, and then it won't be funny anymore. No, I don't have, you don't have tenure,
No one
Jason.
has tenure.
Are you serious?
No.
You get tenure in like
That's
as
right.
a college professor.
Why is Coach Jay gone this week? I don't know. Maybe because you Snapchatted me. Jack, thank you. Okay. So when we approach this one, side angle, or like Hannah wanted to do, angle side, we approach it in such a way where we could have 1, 2, or 0 triangles, all right? Here's where you dial in, all right? I was trying to be funny, but if you remember this because of the ASS triangle, it was completely worth it, okay? Completely worth my job being lost. All right, here we go. All right, here we go. I want you to create a 2x3 or 3x2 just box right here, okay? All right, I'm going to do this in yellow so you can see it. So we've got angle A right across, angle B, and angle C. Okay? The first thing we do when we watch out is we've got to first solve for the angles. So it's all based upon the angles. So A, B, and C are here. We're going to assume that there's 2 triangles every time. That doesn't mean that there will be. We're just assuming that there are. So I'm going to put triangle 1, Illuminati 1, Illuminati 2. Okay? Triangle.
Coach J, you're
I know.
stuff today.
I know. I forgot to get in God's word this morning. I need to get back there. I'm joking. All right. So as we approach this, what is definitive? What is something that is we know already in terms of angles?
A.
equals 30.
A equals 30. They gave that to me, did they not?
They did.
Since they gave it to me, this is important to know. By the way, did you do this last year, the box thing?
No.
I think this really helps. So I don't know. I've just taught it a couple times. I think it helps. Put 30 degrees in both triangles. The reason why is because this was the part that was given. I didn't have to solve that. If I say that this is the angle, then it will always be the angle. Cool? Now for the other angles, we can actually solve for one other one, right? Because I can't solve for the actual angles by subtracting it from 180. But what I could do is do what?
You could do sine A equals sine B.
Good. Sine of A over little a equals sine of B over little b. Cool? And now we're plugging and chugging. Okay? So we got sine of 30 over 10 equals sine of big B over little b, which was 40. Okay? Little different with how we solve this. How do we solve it here? We just cross multiply first, right? So we cross multiply this to get 40 sine of 30. Caitlin, do you want to put that in real quick? Just 40 sine of 30. And then that will be equal to 10 sine of b. Okay? Is 20 right there? Perfect. And then, so we've got 20 here. 20 is equal to 10 sine of big B. How would I solve for sine of B here? Divide by 10. Nice. Okay? Now, here's the kicker. This will be 2 equals sine of B. All right? Right down there is where we're at. How do I get B by itself? This is kind of pulling from other stuff. Inverse sine. Good. Both of y'all get 2 right there. I love it. Take the sine inverse of both sides. Now watch this. If this number is greater than 0, I'm sorry, back up. If it is greater than 1, you will get what? What did we get when we did sine inverse of 2? Anybody get that? Okay, you did an error. Okay, so right here, if that value is greater than 1, you're going to get error, which means what?
What do you do?
It's actually good, Mason. Give yourself 2 there. That means that this is actually no triangle in this instance. Okay? So how do I know that? Well, if it's greater than 1, we would get an error. Therefore, we make it to where there's no triangle that can be created with the information that I gave you here. Okay? All right, questions on that? Y'all feel okay on that? All right, let me backtrack just for a second. Could I do this? Could I make up a scenario real quick where, let's say we did get a triangle? Okay, let's say I got an angle of this. This is where you don't want to fall asleep on. Let's say that angle B was 50 degrees, and that's what I solved for, okay? It wasn't, but let's say it was. In this instance, what would angle C be? Great, good, Caitlin. Give yourself 2. This is 80. Subtracted from 180 would be 100 degrees, okay? So you got to kind of really tune in on this. These two have to add up to be equal to what?
360.
180 because it's with the triangle, right? 180. There's a third place that adds up to be equal to 180. This is the part people forget, okay? There's only 3. So these two make complete sense. I actually will circle those. When I do it, you'll see me if I ever do it here. I'll circle those telling me that it has to add up to be equal to 180. But also the first angle I solved for and its counterpart has to add up to be equal to 180. Okay, what was the first angle I solved for? I gave it to you, but what was the first one I put down? 50 degrees, right? So 50 and its counterpart, whatever the first angle I solved for is, those have to add up to be equal to 180, so what would this one be? 130. Good. Okay? All right, so question. Is it possible to find a third angle of this triangle?
Yes.
Yes. What would it be, David?
20.
20 degrees, because this is 160, and this is 20 degrees. So if I said that this was 50, or if you found out it was 50, then this would have how many triangles possible? 2. Okay? Sometimes this 130 plus the 30 is greater than 180. That means, can I have a third angle? No. So in that instance, it would only be 1 triangle.
Wait, so quick question.
Okay.
Do you always do B or like the second angle that you find, or like does it not work with C?
It would not. So in this instance, a lot of times people will do this. These two add up to be no. Only the first one you solved for. Because notice angle C.
Yeah.
It doesn't, right? Only the first angle I solved for is what it and its counterpart is what adds up to be equal to 180. And again, why are these 30 degrees solid?
Because they gave it to us.
They gave it to us, and if they give it to us, it's like set in stone for both triangles. Okay? All right. And again, for what triangle is this used for, Hannah?
Yes.
How dare you? But you're exactly right. Nicely done. Good. I have to get you in fraction if that's okay, but other than that, we should be good. All right. Questions on that? Cool beans. Hey, can we do one more? We're going to rep this out even more tomorrow. How much time do we got left? 3 minutes? Oh, that's plenty of time. All right, here we go. You ready? Okay. Are these on for your homework?
Y'all.
Yeah? Coach Jay's slacking. All right, go to number 4 real quick. Okay? Yeah, this is good. Angle 4, or number 4. All right, so this is angle A, little a, big B, little b, angle C, side C. By the way, again, we're going to rep this out more tomorrow. So if you're like, man, I'm still a little hazy, we're going to keep doing this. So just as a kind of heads up here. All right, I create my chart, right?
4?
I think this is 4 on your homework, right?
Yeah, I just wanted to see if we're doing 4 or 5. I got you.
What is set in stone here?
120, yeah, 120.
C is 120. Nicely done. So 120. Good, Hannah. Give yourself 2 on that. I love it. A is 4. I always try to circle what I already have. B is 6. Hold up. There's an issue with this, isn't there? Did Coach Jay mess up on how he set this up? He might have. Tell me real quick, what's the problem with this?
You switch B and C.
Yeah, I think I did, didn't I? What type of triangle would this be? Good, Caitlin. Give yourself 2. And then a side angle side. What did we remember about a side angle side back on our chart?
It's
Law of cosines, which we have not done. You're not old enough yet to know that yet, okay? Maybe one day. So this would be the law of cosines, and in this instance, we wouldn't be able to do that. So just as a kind of changing this up real quick, because we'll do this. We'll finish it up tomorrow if need be. Put C as 6. Okay? My fault on that. This should be C is equal to 6 on this one. Cool. All right, so if that's the case, what will we solve for first? What's the only
A.
one I could solve for? A, good, David. Give yourself 2. So we're going to say the sine of big A over what?
Little a.
Little a, which is 4, and then equals sine of 120 over 6. Hey, we'll continue this tomorrow. Okay, cool. We'll go rep these out tomorrow as well, all right?
Wait, so do we just put the sticky note in there?
Yes, if you get tickets, go